All right, so now we're going to start talking about igneous rocks, the first set of rocks that we're going to go through or go over in the rock cycle. First thing you got to know that minerals are found in many types of rocks. So for instance, in this version of pegmatite, you can see you've got plagioclase feldspars, which is more like tannish color. Then you got potassium feldspar. This one's more gray than pink. The one we see in class is pink. This is more muscovite mica, not biotite mica. The difference is you can see this one's more of a lighter brown than the other one. And then quartz. Pegmatite is made up of all of them. Some rocks, these are all minerals, and there's your rock. Some rocks are monomineralic. Important to know the difference between the two. Mono, like mono a mono, one on one, it's composed of only one type of mineral, monomineralic. Whereas most rocks are polymineralic, composed of two or more rocks. In this way, thinking of it this way, rocks are to minerals as letters are to words. So letters make up words, whereas minerals make up rocks. We can classify igneous rocks one of two ways: how they're formed and where they're formed. So the first type, and we're going to look at the three different types eventually. We've got three types of rocks we're going to look at. First is igneous rocks, then we got sedimentary rocks, and then we have metamorphic rocks. So how they're formed and where exactly they're formed, and we'll get to that in a second. So igneous rocks, they form from the cooling and solidification of lava or magma. Lava outside, magma inside the earth. So think of it that way. This is cooling and solidification. And you can absolutely see this in your reference table on page 6. And you'll see I have mine highlighted right up here in this corner. It will tell you by the solidification, that's in my pink, solidification. It doesn't say cooling, but solidification of that magma. And there are two types of igneous rocks, which you can find below that right here. And there are two types, which are right here, which is intrusive. So we're going to start with intrusive, and the next one's number 2. So intrusive, these cool inside the earth. Inside, intrusive. So if magma never erupts and cools slowly in the ground, it becomes intrusive igneous rocks, where we have these 3 types. So we've got this one, we've got this one, and then, even though you guys don't need to know it, I've got this one, this lovely chunky one. All right, so these ones form inside the earth. Because they form inside the earth and they slow really, really coolly, they have large crystals. So that's an identifier that this is igneous, is because it has crystals in it. The second type, which has my favorite type in there, are called extrusive. Exit, outside of the volcano. Instead of inside, intrusive, it's extrusive. It exited the volcano. These form on the surface of the earth. So you have these type right here, and sorry, I've got lots of them, and these two right there. All right, so all of these form outside the earth. And one of the things you're going to notice that because they cool so fast, if they have crystals, they're very, 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 very tiny. They're small, or no crystals at all. You can even see gas pockets. So identifying igneous rocks based on color and texture. So I know we said with minerals that color's a bad thing. However, with igneous rocks, color is important. So color proves to be very helpful in identifying. How so? You have lighter colored and then you have darker colored. So the lighter color, you'll see more like this, and darker color, I don't have one of them, although you've already seen it. But like darker color could be like this. All right. So how dark or light an igneous rock is, it identifies what type of minerals are in there and what type of composition, what it's made up of. All right, so you're going to see this at the bottom of 7. It's kind of interposes onto the the types of rocks. So up here, it's like this could go on top of this section right there. So to determine what type of minerals that can be found in light, medium, and dark igneous rocks, you can see right here it says lighter and darker over here. And all you have to do is take this chunk and follow it down. So the lighter colored are potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole. Whereas the medium colored, this is on the inside, and these are plagioclase feldspar, biotite, amphibole. You got a little bit of quartz and a little bit of pyroxene. Then in my colored, the darker ones, you're going to find plagioclase feldspar, biotite, pyroxene, amphibole, olivine. All of those, olivine tends to be green, so you're going to have the greener here and the lighter pinker over here. All right, so texture, which you're going to see right here. So there's your texture up here where my finger is. You're going to find your texture there. So it provides helpful identifying of igneous rocks. You're going to look at the crystal size, how big they are. So looking at this is glassy. My favorite, this is obsidian. You know that if it's glassy, it has cooled rapidly, like very, very rapidly. Then the next one down, this one, and this one. They have gas pockets in it. Again, pretty fast. And then you're going to have this one right here. It is pink with little flecks in it. That is fine. Very, very small crystal things. And then we're going to start to get bigger crystals. So you're going to have something like this, which is considered coarse because the crystal sizes are a little bit bigger. And then you're going to get very coarse, which would be this one right here. And this tells you how fast they cool. So if it's glassy, it cools like that. This is the one that when it touches water, it goes instantly from molten lava to solid rock. This is obsidian, and you find this in Minecraft. These ones, these come from pyroclastic bombs. Those are the magma or the lava that is thrown out of the volcano, and it forms holes in it, gas pockets, because it's flying through the air, cooling down. So that, again, relatively very fast. Then when you get to this is more on like the side of the volcanoes. Along with this one, you can't really see the crystals in this one, but this one too, those two match. Those are fine, which means relatively fast, but not very, very fast like the first two. And then you get coarse, like this one and this one. Those are coarse. They cool slower. And like this one right here, that's the slowest. All of these from fast are extrusive. All the slow are intrusive. All right, so on page 6 of your reference table, right here, what light-colored igneous rock has fine texture? So you're going to go to the lighter side, which is over on this side. So you're going to choose from over here. And it says fine texture. You're going to go over here to texture, go over here, and we have rhyolite. And it could be vesicular too. It just means gas pockets. What are the size of the crystals found in an igneous rock? What are they directly related to? So the size of the crystal tells you what? It tells you where it is formed, number one, and how fast it solidified. If it's really, really tiny, it is outside of the volcano, extrusive, and it's very slow or very fast or fast. If it has big chunks, big crystals in it, that means it formed inside very slowly. What are the 3 minerals found in the igneous rock, granite, and gabbro? So you're going to look down here, and you're going to see where gabbro and granite are. And you're going to look in these 2 sections and find the 3 that go in both. And the 3 that go in both are, it looks like plagioclase feldspar, biotite is in both, and amphibole is in both. And you'll see that plagioclase here, amphibole, and biotite. Those are in both granite and gabbro. All right, so we're going to look at some of my lovely rocks and try to identify them based on what you've already seen in this. So let's see, which one would be scoria? So if you look at your reference table, scoria is over here. It is on the dark side, like Star Wars. It's on the dark side. So we're going to look for a darker one. And it also says that it is vesicular. How did I find that? It says, sorry, my bad. Right there, vesicular. That means there's gas pockets in it. So I'm going to look for one that is darker and has gas pockets. It's in between these two. So it's got to be number 4. Rhyolite. So again, I'm looking to this, and I find rhyolite right here. It's on the lighter side, and it's fine. So I'm going to look for one that is fine and light right here, number 1. Gabbro. Looking at this, Gabbro's right here. It's on the dark side, and it's coarse. So I'm going to look for one that's kind of bigger, chunky. That'd be number 5. Pumice is the opposite. It's the light side to the dark side of scoria. So it's going to have gas pockets, and it's going to be a light color. That's going to be number 3. By the way, do you know that pumice is the same type of pumice that you scrub on your feet to exfoliate your feet? It is. All right, let's look for granite. Granite is going to be the opposite of gabbro. So gabbro is on the darker side, whereas granite is on the lighter side. So it can't be 5. It's got to be number 7. Obsidian. You cannot mix this up with anything else. I love this. This is what they used to make arrowheads out of. It would be number 2. And pegmatite, that's the one with the big, chunky, huge crystals and kind of green. It's number 6. All right, so that's it for the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.